In this section, we will talk about the properties of inverse trig functions. So remember that sine and inverse sine undo each other. So sine of inverse sine of x is x, cosine of inverse cosine of x is x, tangent of inverse tangent of x is x. Same goes when you have inverse sine of sine, inverse cosine of cosine, inverse tangent of tangent. Now the one thing we're going to be mindful about is as follows. For inverse sine of x, the domain, so the x value, whatever we take the inverse sine of, this is restricted between -1 and 1. And the output is restricted between negative pi over 2 and pi over 2. For inverse cosine of x, same thing. The domain is restricted between -1 and 1. So whatever we take the inverse cosine of has to be between -1 and 1. And the range, the output is limited, restricted between 0 and pi. For tangent, it's a little bit different. The reason that we have a restriction on inverse sine and inverse cosine, because remember, for sine, if we have the sine of any angle equals to opposite over hypotenuse, the hypotenuse always has to be bigger than the numerator. So that means the biggest we can get is -1, and the smallest is -1, the largest is +1. This is for sine or cosine. Cosine is adjacent over hypotenuse. So because the adjacent side has to be smaller than the hypotenuse, we're always going to get a fraction here, or a -1 and 1. Now for tangent, this is opposite over adjacent. There is no hypotenuse here. So for tangent, we can have something like -5 over 2. The opposite side could be -5. So let's say we have this angle here. The opposite side could be -5, the adjacent could be +2. That's completely valid. But that can't happen for sine or cosine, where the denominator is smaller than the numerator, because hypotenuse always has to be the bigger side. So for tangent, we have no restriction on domain. Tangent has no domain restriction. And then remember, the output is same as sine. So we got -pi over 2 less than or equal to y, less than or equal to pi over 2. All right, so let's take a look at the first one. Arc sine is same thing as inverse sine. Inverse sine of sine is just equal to -pi4. Make sure the output is between -pi over 2 and pi over 2, which it is, so this is good. We got sine of the inverse sine of -2.9. Now remember, for arc sine, for inverse sine, this has to be between -1 and 1. -2.9 is not, therefore, this does not exist. Now for tangent, there is no domain restriction because tangent is opposite over adjacent, and the opposite side could be bigger than the adjacent side. That's totally fine. So tangent of arctan of -3.2 is just going to be -3.2. Now lastly, let's take a look at arc sine of -20 pi over 9. So here we get -20 pi over 9 is the output. However, the output is restricted between -pi over 2 and pi over 2. So this is not between -pi over 2 and pi over 2. So this cannot be a valid output for arc sine. But what we can do is we can find a coterminal angle that is between -pi over 2 and pi over 2. So remember, to find coterminal angles, we can add or subtract 2 pi. So since this is less than -pi over 2, I'm going to be adding 2 pi because I want to get closer to -pi over 2. 2 pi over 1, if I get a common denominator, I'm going to multiply the denominator and numerator both by 9. So then this gives us -20 pi over 9 plus 18 pi over 9. And then this will give you -2 pi over 9. Now -2 pi over 9, that is between -pi over 2 and pi over 2. So therefore, this is going to be our valid output. So anytime your output is not between -pi over 2 and pi over 2, you can either add or subtract 2 pi in order to get an angle that is between -pi over 2 and pi over 2. take a look at the next one. We have cosine of arc sine of radical 2 over 2. Now, when you had sine and arc sine, they just undo each other. But when you have cosine and arc sine, they do not undo each other, right? Because they're not the same function. So we have to do it step by step. Remember that any arc sine or any inverse sine, it represents an angle. So we got to figure out what angle is this, and we got to sketch that angle. So let's think back to sections 4.1 and 4.2. If we're talking about arc sine, our output could be in quadrants 1 and 4. If it's positive, it'll be in quadrant 1. If it's negative, it'll be in quadrant 4. In this case, it's positive. So I'm going to sketch a triangle. Now, when I do sketch this triangle, when I sketch my right triangle in quadrant 1, why quadrant 1? Because arc sine is positive. We have to rewrite radical 2 over 2 as 1 over radical 2. This means that for angle x, the opposite is 1, and the hypotenuse is radical 2, making this a 1, 1 radical 2 triangle. Now, what do we want with this? What do we want with this angle? We don't want to find the angle. We know this angle is 45 degrees. We don't want to find that. We want to find the cosine of this angle theta, or let's call this x. We want to find the cosine of angle x. The cosine is adjacent over hypotenuse, so this will be 1 over radical 2, which is simply radical 2 over 2. So step 1, sketch the triangle. And of course, in the correct quadrant. Once you sketch the triangle, fill in the ratios of the sides, and then find the given function. Let's take a look at another example. We have tangent of the inverse sine of radical 3 over 2. So first thing we want to do is we want to sketch this angle x. So we got inverse sine, which means we're going to either be in quadrants 1 or 4. Always start with the parentheses first. In the parentheses, we got inverse sine. So now I'm going to sketch my triangle. And notice that I put it in quadrant 1. The reason it's in quadrant 1 is because sine is positive, so it's going to be in quadrant number 1. Now for angle x, sine is going to be opposite over hypotenuse. So this is opposite over hypotenuse. So opposite of x is going to be radical 3. Hypotenuse is 2, which means the adjacent side is 1. Now I don't want this angle. Opposite of radical 3 is 60 degrees, but I don't want that. I want to know what is the tangent of this angle. So tangent of x is going to be opposite over adjacent, which is going to be radical 3 over 1, or simply radical 3. So sketch the triangle using the inverse sine, and then find the tangent given the ratios. Next, we have cosine of inverse tangent of radical 3 over 3. So once again, we have our tangent, which is going to be either in quadrants 1 or 4. Because it's positive, it'll be in quadrant 1. I think I put too many positives in here. But remember, if it was negative, it would be in quadrant 4. So here's my triangle. Radical 3 over 3, we have to rewrite that as 1 over radical 3. So this is going to be the cosine of the inverse tangent of 1 over radical 3. Okay, now tangent is opposite over adjacent. So we have an angle x, single x, and opposite of angle x is going to be 1, and adjacent is going to be radical 3, which means our hypotenuse is going to be 2, because we have a 1 radical 3, 2 triangle. So if it's tangent, make sure you're at the opposite over the adjacent. I don't want to find angle x. If I did, it would be 30 degrees, because opposite of 1 is 30, but I don't want that. I want the cosine of angle x. And the cosine of angle x is going to be radical 3 over 2, adjacent over hypotenuse. So that is my ratio. So once again, the steps are use the inverse to sketch the triangle. And then fill in the ratios. And once you've done that, find the outer function. Find the ratio of the outer function. So in this case, we sketched the triangle using opposite over adjacent, and then we found the cosine by doing adjacent over hypotenuse. Okay, if you have any questions, come prepared in class. Let's do another one. We have the tangent of the inverse sine of 12 over 13. So first off, we have to sketch angle x. Now, once again, sine is going to be in quadrants 1 and 4. Sorry, I had to pause, so this might seem off. I forgot where I left off, but we sketch angle x. Inverse sine is going to be either in quadrants 1 or 4. It'll be in quadrant 1 because sine is positive. Now, for angle x, opposite is 12, and the hypotenuse is 13. So we have 12 over 13. We want to find out what is the adjacent side. So if we do a squared plus b squared equals to c squared, I'm going to have a squared plus 144 equals to 169, which means a squared is equal to 25 if I subtract 144 from each side, and then a is going to be plus or minus 5. Because we're going in the positive direction, it'll be positive 5. Now, we don't want the value of angle x. We want to know what is the tangent of this angle. Tangent is opposite over adjacent. So tangent of this angle is going to be 12 over 5, opposite over adjacent.